Welcome back students. As you know, we are dealing with chapter 2 of science, that is matter around us pure? In the last lecture we studied classification of matter as pure and impure substance. Pure substances are classified as elements and compounds, and impure substances are called mixtures. These mixtures can again be classified as homogeneous and heterogeneous mixture. Now let us study other topics of this chapter. So here we are going to study about solution. We know that a mixture can be in any state, that is solid, liquid or gaseous state. If it is in a liquid state, it is called solution. So what is a solution? A solution is a homogeneous mixture of two or more substances. A solution is made up of two parts, the solute and the solvent. A solute is the substance being dissolved and the solvent is a substance the solute is being dissolved in, and it is often a liquid. So first of all, solution is a homogeneous mixture which is made up of two or more substances. Now there are two parts of a solution, the solute and the solvent. The substance which is getting dissolved is called solute, and the substance which is dissolving the solute is called solvent. Now here students, one thing you have to keep in mind, that the amount of solute will be less in the solution compared to solvent. For example, if we take this solution of sugar in water, here sugar is a solute and water is a solvent because sugar is getting dissolved in water, and obviously sugar solution, the amount of sugar is less compared to water. And one more thing you have to keep in mind, that water is considered as universal solvent. Most of the substances are getting dissolved in water. So in the short answers it can be asked, dash is considered as a universal solvent, then it is water. Students, these are some of the examples of solution. First one, a solution of sugar in water is a solid in liquid solution. In this solution, sugar is a solute and water is a solvent. We have already discussed it. Second, a solution of iodine in alcohol is known as tincture of iodine. Has iodine, that is solid, as a solute, and alcohol, that is liquid, as a solvent. Third, aerated drinks like soda water etc. are gas in liquid solution. This solution contains carbon dioxide, which is a gas, as a solute, and water, which is a liquid, as a solvent. Fourth one, air is a mixture of gas in gas. Air is a homogeneous mixture of number of gases. It contains mainly two constituents, oxygen 21% and nitrogen 78%. And other gases are present in very small quantity. Now students, let us study the properties of a solution. A solution is a homogeneous mixture. The particles of solution are smaller than 1 nanometer. Nanometer means 10 raised to minus 9 meter in diameter. So they cannot be seen by naked eye. Because of very small particle size, they do not scatter the beam of light passing through the solution. So the path of light is not visible in the solution. So first of all, what is scattering of light? Scattering of light is splitting of light in different directions. But since the particle in the solution are very small, they cannot scatter or split the beam of light. So the path of light is not visible in a solution. Next property, the solute particles cannot be separated from a mixture by the process of filtration. The solute particles do not settle down when left undisturbed. That is, a solution is a stable solution. When sugar is dissolved in water, you can't separate sugar and water by the process of filtration. If you leave this sugar solution for some time as it is, the sugar will not get settled down in the glass. So, this solution is a stable solution. Let us see some more things about solution. At any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be a saturated solution. Or in other words, you can say that when no more solute can be dissolved in a solution at a given temperature, it is called saturated solution. Which means that when you start dissolving this solute in a solvent of a particular solution at a given temperature, a time will come when no more solute can be dissolved in it, and such a solution is called a saturated solution. The amount of solute present in the saturated solution at this temperature is called its solubility. If the amount of solute contained in a solution is less than the saturation level, then it is called unsaturated solution, which means that if you dissolve 1 spoon of sugar in 1 glass of water, then it is unsaturated solution because it is having capacity of dissolving more sugar. Students, from this diagram it will be clear to you what is saturated and unsaturated solution. Here the solution of copper sulfate is there in 3 beakers. In the first beaker you can see dilute and unsaturated solution is there, which means that proportion of water is much more than copper sulfate. So it is dilute or weak unsaturated solution. Now if more copper sulfate is added, it becomes concentrated solution. If again more copper sulfate is added, then it becomes saturated solution, which means that after that copper sulfate will not be able to get dissolved in it. The concentration of a solution is the amount of solute present in given amount of solution or amount of solute dissolved in given mass or volume of solvent. So concentration of solution is equal to amount of solute upon amount of solution, or you can say amount of solute upon amount of solvent. So this is the formula for concentration of solution, and it is the amount of solute present in given amount of solution or solvent. There are various ways for expressing the concentration of solution, but here we will use only 2 methods. First one is mass by mass percentage of solution. This can be used if solute and solution are given in terms of mass. That is, for example, 25 gram of solute and 500 gram of solution. Then you can use this formula to find the concentration of solution. The formula is mass of solute upon mass of solution into 100. Second is mass by volume percentage of solution. Suppose that solute is 25 gram, the volume of solution is 1 liter. Then you can use this formula, that is mass of solute upon volume of solution into 100. Let us see the example given in your textbook so that it will be more clear to you how to find the concentration of solution. Example 2.1. A solution contains 40 gram of common salt into 320 gram of water. Calculate concentration in terms of mass by mass percentage of solution. So here the solute is salt and solvent is water. So mass of solute is 40 gram and mass of solvent is 320 gram. Now we know that solution is made by mixing solute and solvent. So mass of the solution will be mass of solute plus mass of solvent, that is 40 gram plus 320 gram, that is equal to 360 gram. Now we have to find the concentration in terms of mass by mass percentage of solution. So the formula is mass of solute upon mass of solution into 100. Mass of solute is 40 and mass of solution is 360. So 40 upon 360 into 100, which is equal to 11.1%. So students, we studied about solution, which is a type of homogeneous mixture. Now we are going to study about types of heterogeneous mixture, that is suspension and colloidal solution, or you can say mixture. So first of all, let us see about suspension solution. When solids are dispersed in liquids, they are called suspensions. A suspension is a heterogeneous mixture in which solute particles do not dissolve but remain suspended throughout the bulk of medium. Particles of suspension are visible to naked eye. Students, if you consider the solution of chalk powder in water, you will be clearly able to see the chalk powders, because here in this type of solution, solute particle is not getting dissolved in the solvent, that is chalk powder will not get dissolved in water. So such type of solution is called suspension solution. You can say suspension mixture. Now let us see the properties of suspension. Suspension is a heterogeneous mixture, we are already knowing it. The particles of suspension can be seen by naked eye. The particles of suspension scatter a beam of light passing through it and makes its path visible. So if beam of light is passed through suspension, then the particles scatter that beam of light and the path of light will also be seen clearly. Next, the solute particles settle down when a suspension is left undisturbed. That is, a suspension is unstable. They can be separated from a mixture by the process of filtration. So, if the suspension solution is left undisturbed for some time, then solute particles will get settled down in the bottom of the vessel, and this solute particles can be separated by method of filtration. If you filter the solution of chalk powder with water, chalk powder can be filtered out. So, these are the properties of suspension. Next is colloidal solution. Colloidal solution is a heterogeneous mixture in which particle size of substance is intermediate of true solution and suspension, which means that in colloidal solution the particles will be bigger than true solution, or you can call it as a solution, and smaller than suspension solution, that is between 1 to 1000 nanometer. Smoke coming from fire is an example of colloidal system in which tiny particles of solid floats in air. Just like solution, or you can call it as true solution, colloidal particles are small enough and cannot be seen through naked eye. They easily pass through filter paper. But colloidal particles are big enough to be blocked by parchment paper or animal size. For example, air. Air is a colloidal mixture. The particles are bigger in size than true solution, or you can just call it as a solution, but smaller than suspension solution. But you cannot see those particles. Properties of colloid. A colloid is a heterogeneous mixture. Size of particles of colloid is too small but individually seen by naked eyes. Colloids are big enough to scatter a beam of light passing through it and makes the path visible. So, when a light is passed through colloidal solution, the path of light is clearly seen. They do not settle down when left undisturbed, so it is a stable solution. They cannot be separated from mixtures by the process of filtration, but a special technique of separation known as centrifugation can be used to separate the colloidal particles. So, they cannot be separated by filtration, but a technique called centrifugation can be used to separate them. Let us understand true solution, which is also called solution, colloidal solution and suspension solution with example. Consider a solution of sugar in water. You know that it is a homogeneous mixture. So it is a solution and solute is completely getting dissolved in solvent, and we can't see the solute particles when it is dissolved. Now take the solution of chalk powder in water. Here solute is not getting dissolved in solvent and we can see the solute particles clearly. Consider another example, air. Air is a heterogeneous mixture of smoke particles, dust particles, etc. But these smoke particles, dust particles are not dissolved in air, but it appears as if they are dissolved in air. So it is a colloidal solution. So in true solution or solution, solute is completely getting dissolved. In suspension solution, solute is not getting dissolved, and in colloidal solution, solute is not getting dissolved but it is appearing as if it is dissolved. This is the difference between all these three solutions. Students, here in the diagram you can see that a flash of light is passed through solution, which is also called true solution, colloid and suspension. You can see that in true solution or solution path is not visible, but in colloid or suspension solution path is visible. This topic is very important. Many times in the exam they have asked the difference between colloidal suspension or true solution, or properties of a particular mixture like colloid or suspension is asked. So prepare this topic very well. Now students, we are going to study about very important effect which is known as Tyndall effect. When a beam of light is passed through colloidal solution, the colloidal particles scatter the beam of light and path of light becomes visible in the solution. This effect is called Tyndall effect because it was found out by Tyndall named scientist. Tyndall effect can be seen when light enters a room through a small hole due to scattering of light by dust and smoke particles. This all of you have seen that a closed room is there, and if a light is entering in the room through a small hole, you can clearly see the path of light along with some dust particles in the air also. Here in the diagram also it is clearly seen. Tyndall effect can be seen in dense forest due to scattering of light by water droplets in mist. This is also seen in the diagram. This is another diagram in which Tyndall effect can be observed clearly through a canopy of dense forest. In the forest, mist contains tiny droplets of water which acts as a particle of colloid dispersed in air. Let us study about colloidal solution in detail. The components of colloidal solution are the dispersed phase and dispersed medium. The solute-like component or dispersed particle in a colloid form dispersed phase. So the components which are like solute, the particles which are dispersed in the colloid, they form the dispersed phase of colloidal solution, and the component in which dispersed phase is suspended is called dispersing medium. Colloids are classified according to state, that is solid, liquid or gases, of dispersing medium and dispersed phase. Let us see some of the examples so that it can be clear to you. The table represents common examples of colloids. If we consider fog, clouds, mist, etc., they are the type of colloid called aerosol. Here the dispersed phase is liquid and dispersing medium is gas. Second one, smoke, exhaust from the automobiles, that is from the vehicles, is also a type called aerosol. Here dispersing phase is solid and dispersing medium is gas, that is solid is dispersed phase in the medium which is gas. Next is shaving cream. It is a type of colloid called foam. Here dispersed phase is gas and dispersing medium is liquid. Milk, face cream, etc. They are the type of colloid called emulsion. Here the dispersed phase is liquid and dispersing medium is also liquid. Milk of magnesia, mud. They belong to type of colloid called sol. Here dispersed phase is solid and dispersing medium is liquid. Next is foam, rubber, sponge, etc. The type of colloid is foam. Here dispersed phase is gas and dispersing medium is solid. Next is jelly, cheese, butter, etc. They belong to type of colloid called gel. Here dispersed phase is liquid and dispersing medium is solid. Last one is colored gemstone, milky glass, etc. They belong to type of colloid called solid gel. Dispersed phase is solid and dispersing medium is also solid. Students, you need not have to by heart this table. Sometimes short answers are asked from this table. So with this we conclude our lecture. In this lecture we studied very important part of this chapter, that is types of mixtures in detail, that is type of homogeneous mixture which is called solution or true solution, and type of heterogeneous mixture which is called colloidal or suspension solution.